All right, guys, here we go. Unit 7, which is air pollution. And we need to make sure that whenever we talk about air pollution, that we're actually not using the word air pollution, but that we're using the word air pollutants, and that you're very specific about the particular pollutant that you're talking about. If you just throw around the word, the problem is air pollution, you're not going to get credit for it. So you need to be able to identify the sources and the effects of various air pollutants. And we'll go through all of these, all of this essential knowledge throughout the video here. So one of the things, like I said at the very start, is that you have to write about pollutants, the specific molecule or particles, not just pollution in general, as an idea, because you have to prove that you have college level knowledge. So one of the things to keep in mind is that in 1970, the Clean Air Act was passed, and it identified 6 criteria air pollutants that the EPA required, um, set acceptable limits for, to monitor these pollutants, and then to enforce whether these pollutants were being released into the atmosphere. And so these 6 criteria air pollutants that we're going to talk about are SO2, which is sulfur dioxide, and this comes primarily from coal combustion in terms of electricity generation. And as a result, it can be a respiratory irritant. It is an ingredient in smog, and it can also lead to acidic precipitation or acid rain. Nitrogen oxides, which we often call NOx because it's either NO or NO2, this is coming from fossil fuel combustion, so especially from the tailpipes of our cars. And when it combines with O3, it can be, or it is a key ingredient in photochemical smog. It can also create acidic precipitation as well. Carbon monoxide is our third criteria air pollutant, and it comes from the incomplete combustion of fossil fuels. So this could be coming from car engines, it could be coming from furnaces, things like that. And it is absolutely lethal to humans. We'll talk more about that. Lead is coming from a metal plant, so the making of metal and smelting of metal. It's coming from the burning of waste, particularly medical waste. And the problem with lead is that it's a neurotoxicant, and so it can be damaging to our brains. O3 is tropospheric ozone. Now, remember that ozone in the stratosphere is a good thing, but ozone in the troposphere is not. And so, tropospheric ozone leads to the photochemical oxidation of nitrogen dioxide, and then that leads to the formation of photochemical smog, which can damage the photosynthetic capabilities of plants, and it's also considered a respiratory irritant. And then the last criteria air pollutant is particulate matter, and particulate matter particularly comes from fossil fuel combustion and also biomass combustion. It is a respiratory irritant and also can lead to smog formation. So the other thing to note is the thing that wasn't listed in those 6 criteria air pollutants is carbon dioxide. And so while carbon dioxide is a greenhouse gas and is something that can lead to global climate change, it is not one of the 6 criteria air pollutants because it's not, harmful for us to breathe. It's not directly impacting human health. Although in 2007, the Supreme Court ruled that the EPA could regulate greenhouse gases. And so, because of that, the EPA can regulate carbon dioxide, and they began doing so in 2009. So, one of the things to realize and remember is that carbon dioxide does not directly lower air quality from a human health standpoint. So it's not toxic for us to breathe. It's not going to damage our eyes and lungs. It's not going to lead to smog formation and decreased visibility, which are the reasons that those other things are considered criteria air pollutants and carbon dioxide isn't. But carbon dioxide is a greenhouse gas, and it does lead to the warming of the atmosphere, and thus, as a result, these indirect human health consequences, which is what the basis for that Supreme Court ruling was in 2007. So, bottom line, when you're answering free response questions, it's a pretty good idea to steer clear of talking about carbon dioxide as a pollutant because it's typically not considered an air pollutant. So you want to stick to the ones that we know are considered pollutants: sulfur dioxide, nitrogen oxides, ozone, particulate matter. So if we kind of look more carefully at some of these criteria air pollutants, coal combustion in general releases more air pollutants than any of the other fossil fuels. And currently, about 35% of global electricity is coming from the combustion of coal, although that number is steadily decreasing as we move towards more towards natural gas combustion and the use of renewables. So, what's the deal? What's the problem? Coal combustion is just pretty much bad in general. It's going to release carbon monoxide, carbon dioxide, sulfur dioxide, nitrogen oxides, toxic metals like mercury, arsenic, and lead, and particulate matter. So it kind of hits all of them. But the one that coal is particularly known for is the release of sulfur dioxide. And so let's talk about particularly the impacts of sulfur dioxide. And so sulfur dioxide in the atmosphere is considered a respiratory irritant. So it's going to exacerbate kind of inflammation of the bronchioles of your lungs. If you have asthma, it's going to make it worse, can lead to chronic bronchitis. And then those sulfur aerosols, which are these suspended sulfur particulates, can reduce visibility. So it can block incoming sunlight, which reduces visibility, and also can reduce photosynthetic activity. It can form a sulfurous gray smog. So this is different than photochemical smog. Sulfur dioxide is not an ingredient in photochemical smog, but it can form this like London type fog. And then when it combines with water and oxygen in the atmosphere, it can form sulfuric acid, which in turn leads to acid rain or acid snow, acid precipitation of any kind. So the next criteria air pollutant are these nitrogen oxides, which we typically call NOx, so though it's important to be specific, is it NO or is it NO2? And basically, these are released by the combustion of anything. So anything that you're burning is going to release NOx, especially fossil fuels and biomass. So NO forms when we have nitrogen gas in the atmosphere and that combines with oxygen. So this is particularly prevalent during combustion. NO can become or turn into NO2 if it reacts with ozone or just oxygen in the atmosphere. And then there's a process that we'll talk more about, but where sunlight converts nitrogen dioxide back to nitrogen oxide. right? And so that's just your kind of chemical illustration of what that's talking about. So human health impacts of nitrogen oxides. It's a respiratory irritant. Honestly, if you don't know the answer of what the problem is with an air pollutant, you can pretty much count on that it's going to be a respiratory irritant. But it also leads to tropospheric ozone formation, which is a precursor or an ingredient to photochemical smog. In addition, just like sulfur dioxide, nitrogen oxides are going to combine with water and oxygen in the atmosphere, and they're going to form nitric acid, which leads to acid precipitation. So lead is another criteria air pollutant, and before the Clean Air Act, lead was a common additive in gasoline. It kind of prevented this idea of like a knocking engine. And so it was really common in our gasoline, but the EPA started to phase it out of gasoline beginning in about 1974. So after 1974, all vehicles manufactured in the US were required to have a catalytic converter, which is a pollution control device on the tailpipe, which reduces the nitrogen oxide emissions and also reduces our carbon monoxide emissions. But the reason that we started to phase lead out of gasoline is because lead actually damages the catalytic converters, and also it's known as a neurotoxicant. So lead can cause pretty significant damage to the human nervous system. So it's also not good to be putting lead in our atmosphere. So as you can see by this graph, this phase out of lead from gasoline and this kind of regulation of lead by the EPA has been really successful. And so our concentrations of lead in the atmosphere have really, really declined precipitously since the early 80s or 80s in general. So one of the other things to note is this idea of a primary air pollutant versus a secondary air pollutant. So a primary air pollutant is going to be emitted directly from a source. So this is a pollutant that's coming directly out of vehicles or directly from factories or power plants, or it could be a natural source as well, things coming directly from volcanoes or forest fires. So our primary pollutants are nitrogen oxides, our carbon monoxide, our carbon dioxide. Remember, it's not a criteria air pollutant. VOCs, which are volatile organic compounds, our SO2s, our sulfur dioxide, our particulate matter, and our hydrocarbons. Whereas our secondary pollutants, these are primary pollutants that have transformed either in the presence of sunlight or the presence of water or oxygen to become a secondary pollutant. And so most of the time our secondary pollutants occur more during the day because sunlight is one of the drivers of these processes. But our secondary air pollutants are ozone, which is a criteria air pollutant, and then sulfuric acid and sulfate, which are forming from our primary air pollutant, sulfur dioxide, and then nitric acid and nitrate, which are forming from our primary pollutant, nitrogen dioxide. So the FRQ that I would like you to practice is this. EPA scientists performed an experiment where coal was burned in different chambers at varying temperatures to see how temperature impacts the amount of nitrogen oxides produced by coal combustion. So I want you to look at those results over there on the graph and then explain how the results of this study would be expected to change if the same experiment were repeated with natural gas. So go ahead and try to see if you can take a stab at that one and we will talk about it. All right. Have a good one. Thanks, guys.